So today I want to talk about trigonometry in a right angle triangle, which is something that for some reason often causes people a certain amount of anxiety. And if it has ever caused you anxiety, I hope by the end of today you'll see it for the really simple idea that it truly is. I want to start with something that isn't trigonometry, but is closely related, and it's something that most of us know very well, and that's the Pythagorean theorem. Remember, if we have a right angle triangle, I'll put my right angle right there, and I'll call this side A. That's the length of that side, and I'll say the length of that side is B, and the length of this side opposite to the right angle. By the way, the side in a right angle triangle opposite to the right angle is always the longest side, and we call it the hypotenuse. We'll call that the length of that C. The Pythagorean theorem just tells us that a squared plus b squared equals c squared. And I am very willing to believe that you know how to use the Pythagorean theorem very well. If you know two sides in a right angle triangle, you can use the Pythagorean theorem to work out the third side. So let's say we have a triangle, the right angle, and this side has length 3, and this side has length 4, and I'm going to ask you to find the length of the hypotenuse. Well, 3 squared plus 4 squared equals c squared. So 3 squared is 9, and 4 squared is 16. 9 plus 16 is 25. 25 equals c squared, so that means c is the square root of 25. And we know it's got to be positive since it's a length. And so square root of 25 is 5. If I gave you two other sides, let's say I gave you another triangle. Let me give you a longer, skinnier triangle. Still with a right angle. And let's say this side has length 13 and this side has length 12, and we'll call that side A again, just for the sake of argument. And I ask you to find A. Well, you know that a squared plus 12 squared equals 13 squared. In other words, a squared plus 12 squared, that's 144, equals 13 squared, that's 169. And so if we take 169 and subtract off 144, we get a squared equals 25. And so a is again the square root of 25, which you already know is 5. So if I give you any two sides in a right angle triangle, you can use the Pythagorean theorem to work out the third side. Now I want to start talking about something that is trigonometry. So let me just draw you a right angle triangle. And I'm going to call, so far we haven't talked about the angles in the triangle, but this time we will. We'll call the measure of this angle, I'm going to use the Greek letter theta to describe that angle, the measure of that angle. And today I'm going to measure all these angles in degrees. That's the way people normally see right angle trigonometry for the first time. And of course you could do the same thing in radians, but we'll do our computations in degrees. Make sure for today your calculator is set in degrees. So the letter theta is just a circle with a line horizontally through it. Now, relative to this angle, we still have this side, which is opposite to the right angle. We'll still call that the hypotenuse, and I'll just write HYP to stand for hypotenuse. And we have this side furthest away from the angle theta. I'll call that the opposite side. So everything is measured to whichever angle we're concerned with. This is the opposite side. And this side is right next to this angle. We'll call that the adjacent side, adjacent right next door. And there are three trigonometric ratios that people generally learn right off the bat. The first is sine. Sine of theta. Sine of theta is equal to the opposite side, the length of the opposite side divided by the hypotenuse. Then there's another one called cosine, and that's the length of the adjacent side divided by the hypotenuse. And there's another one called tangent, and that's the length of the opposite side divided by the adjacent side. And there are three more trigonometric ratios that are the reciprocals of those, where you turn everything upside down. If you turn sine upside down, it's called cosecant, and so on. But I just want to talk about these three today. There's a mnemonic that's always floating around to help people remember what sine and cosine and tangent are. It's sine is the opposite over the hypotenuse, and cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. SOHCAHTOA. It's ubiquitous. All my students seem to know that if they've ever taken a trigonometry course before. If it helps, it helps. If you don't like it, don't bother. But we do need to know what sine and cosine and tangent are. Now here is the central idea behind right-angle trigonometry. In the Pythagorean theorem, if you knew two sides, you could work out the third. In right-angle trigonometry, if you know the length of one side, and you also know one of the non-right angles, there's two of them, then you can work out the length of any other side you want. So let's start with an example. Let's say I have a triangle. And I have a right angle right here. And let's say this angle right here is 25 degrees. By the way, we automatically know what this angle is because all the angles in a triangle add up to 180 degrees. This one's already 90, this one's 25. If you work it out, that one's got to be 65 degrees. But that's beside the point. Let's say we know that this side over here is 10 meters, and I want to know the length of that side. So I know that this angle, I know the length of this side, I want to know the length of that side. So if you're wondering which of the trigonometric ratios we're using, pay attention to the side we know and the side we want to know. We want to know the hypotenuse. We do know the opposite side. Which trigonometric ratio involves the opposite side and the hypotenuse? Opposite and hypotenuse. It's the only one of the three that I have on the board that involves those two sides. So sine, we're going to use the sine because that involves the opposite and the hypotenuse. Sine of 25 degrees equals the opposite, which in this case is 10 meters, over the hypotenuse, which I just call L. We have a nice little equation there. Let's go ahead and try to get L by itself, since that's what we're solving for. So if I multiply both sides by L, I end up with L times sine of 25 degrees equals 10 meters. I'm going to divide both sides by sine of 25 degrees. So L equals 10 meters divided by sine of 25 degrees. That's about as far as we can get without using a calculator or a computer or something. Because at some point, we're going to need to know a decimal value for the sine of 25 degrees. As it turns out, the sine of 25 degrees is about 0.4226. So we're just going to use a calculator here. 10 meters divided by 0.4226. And again, make sure that your calculator or whatever, or your, whatever system you're using, a computer, is set in degrees, or you're going to get the wrong answer. Make sure it's set in degrees. And if we just do that division, 10 divided by 0.4226, we get about 23. So this is approximately equal to, this is equal to 23.66. And of course, we measured this in meters. That's all there is to trigonometry. Just like the Pythagorean theorem, where if you know two sides, you can work out the third side. In trigonometry, if you know one side and you know one of the non-right angles, you can work out whichever other side you want. If we wanted to work out this side, we could have used tangent, because tangent involves opposite and the adjacent. Of course, right now that we know the length of this side, now we know it's 23.66. We don't need any trigonometry at all to work it out, because we could just use the Pythagorean theorem. We know two sides of the triangle now because we worked out the second side. Let's do another example. So this is an actual way people use trigonometry. Let's say we have the ground and we have a tree over here. And we want to know the height of this tree. I'll call this height h. That's what we want to know. Of course, climbing to the top of a tree may not be a very easy proposition. So instead, what we do is we measure a distance along the ground. So that's easy to do. We can easily, take our tape measure or a trundle wheel, if you know what that is, and measure a certain distance on the ground. And let's say that works out to be 40 feet. Actually, let's make it 50 feet. Make it 50 feet. And we take our little protractor here and sight the top of the tree. It's supposed to be a straight line. Doesn't look very straight. Sorry about that. We'll sight the top of the tree, and we can measure this angle, and let's say that works out to be 30 degrees. So measuring the height of the tree directly, that might be difficult, but we sight 30 degrees and we measure this as 50 feet. And I want to know h. I want to know this height right here. Well, it's time to use trigonometry. Which of the trigonometric ratios do we use? Sine, cosine, or tangent? I know this side. I want to know this side. The two sides that are involved in this are the opposite and the adjacent to this angle. Opposite and adjacent, they're part of the tangent ratio. So tan of 30 degrees is going to be the opposite, which is just h, over the adjacent, which is 50 feet. So if I multiply both sides by 50 feet, I'm going to turn everything around and put the h on this side. H is just going to be tan of 30 times 50 feet. Some of you may know tan of 30 degrees off by heart. I'm just going to give a decimal value. It's about 0.5774. We can easily use a calculator to find that, times 50 feet. And if you take 0.5774 and multiply by 50 feet, you get about 28.87. And again, I've measured that in feet. That's all there is to trigonometry in a right angle triangle. If you happen to know one of the non-right angles, you have to know the length of one of the sides, you can work out whichever other side you want.